Alright, well hello, welcome to this video. What we're going to do is we're going to figure out the maximum flow that can go from node 1 to node 6 in this network by applying the augmenting path algorithm to find the max flow. What we'll do towards the end is we'll talk about how we can use the final residual network in the augmenting path algorithm to figure out what the min cut in this network is as well. What we're looking at right now is a network with the arcs. Each arc in the network is labeled with its capacity. So the first step in applying the augmenting path algorithm is we need to create the residual network associated with the current flow level. Currently, we haven't put any flow on any of the arcs yet, so current flow on all these arcs are 0. So right now, we have that xij is equal to 0 for all arcs ij. Now, if you remember what a residual capacity of an arc is, it's if it's a original arc in the network. So for example, arc 1, 2 is an original arc in the network. It's the unused capacity of that arc. So since x12 is currently 0, the capacity of arc 1, 2 is 3. We have a residual capacity of 3. Now, there's also kind of residual capacities of the backwards arcs for the arcs in the network. So we have the concept of residual capacity of arc 2, 1. That is the amount of flow, that's equal to the amount of flow currently on arc x12, on arc 1, 2. And that residual capacity represents how much we can decrease the flow on arc 1, 2 by in walking backwards along the arc 2, 1. So that's the definition of the residual capacities for both the forward and backwards arcs. What is nice is, based on those definitions, the residual capacities of the network, when all the flows are 0, are simply the capacities of the arcs in the network. And all the residual capacities of the backwards arcs are set equal to 0. So what we can essentially do is we can start working with this network, and instead of having uij, we really have rij already given to us. So we're going to just kind of move on to the next picture, and all that changed from that previous picture to this previous picture is we have the rij designated up top. Now, we're interested in maximizing the flow from node 1 to node 6. So the way the augmenting path algorithm works is that first step is we're going to determine if we can find a path from node 1 to node 6 in the residual network. Any path will do. There is kind of an advantage of taking paths that contain a small number of arcs. So that's kind of will be our initial goal. So if I look, I can start at node 1. I can take arc 1, 2. I can then take arc 2, 4. And then I can take arc 4, 6. So the red arcs are a path from 1 to 6 in the residual network composed of arcs with positive residual capacity. So our path P is composed of arcs 1, 2, arc 2, 4, and then arc 4, 6. And what we're going to do along this path is we are going to use it for all it is worth. So we're going to try and put as much flow on this path as possible. Equivalently, the amount of flow we're going to augment along this path is equal to the minimum of the residual capacities of the arcs on the path. So we're looking at min R12, R24, and R46. And currently, it turns out that all of these arcs have residual capacities of 3. So I know what I'm going to do is I'm going to push 3 units of flow along this path. By doing so, I'm going to have to change the residual capacities of both the forward arcs and the backwards arcs along this path. For forward arcs, so arc 1, 2, we are going to decrease its residual capacity by the amount, by this delta amount, by the amount we're pushing along the path. So residual capacity of arc 1, 2 is going to decrease from 3 to 0 because we're pushing 3 units of flow along it. So arc 1, 2 is going to disappear from our residual network. Because once you have a residual capacity 0, you're no use to us anymore in the residual network. Now, for the backwards arc 2, 1, we just put 3 units of flow on arc 1, 2. So that means potentially we can decrease the flow on arc 1, 2 in later stages. So that means we'll increase the residual capacity of arc to 1 by the amount delta that we're pushing along. So what we're going to do is we're going to go to kind of the bare bones next network. What we will do is we'll just simply copy over the residual capacity of the arcs that are unaffected by that path we just did. So residual capacity of 1, 3 remains 4. Residual capacity of 3, 5 remains 2. Residual capacity of 3, 4 remains 1. Residual capacity of 2, 5 remains 1. And the residual capacity of 5, 6 remains 5. And now we're going to replace and kind of update the residual capacities of the arcs along the path. So like I said before, we're going to push 3 units of flow along arc 1, 2, which means its residual capacity is going to decrease to 0. It's no longer going to appear in the network, but the backwards arc from 2 to 1 will appear with a residual capacity of 3. Arc 2, 4 had a residual capacity of 3 before we pushed 3 units of flow on it, so its residual capacity drops to 0. But we are going to have arc 4, 2 appear in the network with a residual capacity of 3. Same story for 4, 6. Its residual capacity started at 3, pushed 3 units of flow along the path. It drops down to 0, so arc 4, 6 disappears from the residual network. And then arc 4, 6 appears with a residual capacity of 3. So what we've basically done here is we have successfully implemented one step or one iteration of the augmenting path algorithm. And we repeat. We basically now look at this network and try and find a path from node 1 to node 6. So in this case, again, we're going to go with kind of shorter paths. We'll move from 1 to 3, move from 3 to 5, and then we can move from 5 to 6 and reach node 6. So our path P contains arcs 1, 3, 3, 5, and then 5, 6. And then we're going to look at calculating our delta, so how much flow we're pushing along this path, by looking at the minimum of the residual capacities of these arcs. So min R13, R35, and R56, which is equal to the minimum of 4, 2, and 5. So our residual capacity, or the delta, how much flow we're pushing along this path, is set equal to 2. And we're going to do similar updates to what we just did in the previous step. We now need to update the residual capacities of all the arcs along this path. So first thing I'm going to do is I'm going to draw in the arcs that in the network that were not included in this path. So the residual capacity of those arcs and their backwards arcs will not change. So all I'm doing, all the arcs that didn't appear, nothing changes about them or their backwards arcs. And now for each of these red arcs, I need to update the residual capacities. I'm going to decrease the amount I'm pushing along this path is 2. I'm going to decrease their residual capacities by 2 and increase the residual capacity of their backwards arcs by 2. So we still have arc 1, 3. It had a residual capacity of 4. We're going to decrease it by 2, so it ends up with a residual capacity of 2. Arc 3, 1 had a residual capacity of 0. Since it's the backwards arc, we're going to increase the residual capacity by the delta, or equivalent to 2. So arc 3, 1 now has a backwards residual capacity of 3. Arc 3, 5 had a residual capacity of 2. We decrease it by 2. It ends up having a residual capacity of 0, so it leaves the network. But we add in arc 5, 3 with the residual capacity of 2. And then 5, 6 had a residual capacity of 5. It decreases to having a residual capacity of 3. And then the backwards arc 6, 5 ends up with a residual capacity of 2. And we repeat. We have another residual network. We try and find a way to go from 1 to 6. So looking at this network, I can leave node 1. I can go from node 1. I can go to then node 3. From node 3, the only way out of node 3 is to go from 3 to 4. Only way to get out of node 4 in the residual network is to go to node 2. Only way to leave node 2 is to head towards node 5. And the only way to get out of node 5 is to head towards node 6, which is good because we just found another path from 1 to 6. So I'm happy we can push flow along this path. So our path P is composed of arcs 1, 3, 3, 4, 4, 2, 2, 5, and then 5, 6. And again, our delta is equal to the min across all arcs in path P. So any arc in path P of Rij. And so we're taking the minimum of 2, 1, 3, 1, and 3. So this delta is going to be equal to 1, where both arcs 3, 4, and 2, 5 had their residual capacities equal to 1. So this is a little bit more of a complicated problem to kind of, or this more, not complicated problem, complicated residual network to update because so many of the residual arcs will have their flows changed. So again, we'll just start by drawing the flows on the arcs where the that are not impacted by this change in the residual capacity or change in the path, not impacted by the path we just selected. So now we're going to push 1 unit of flow along the red path. So we need to decrease the residual capacities of the forward arcs in that path by 1 and increase the residual capacities of the backwards arcs by 1. So arc 1, 3 will still be in the residual network. Now it just has a residual capacity of, instead of having 2, we decrease it by 1, has a residual capacity of 1. And then arc 3, 1 had a residual capacity of 2. It updates to having a residual capacity of 3. Arc 3, 4 had a residual capacity of 1. Its residual capacity decreases to 0, but we increase the residual capacity of the backwards arc from 4 to 3 to 1. Now if we look at arc 2, 4, or sorry, not arc 2, 4, 4, 2, its residual capacity was 3. We're going to decrease that by 1 to 2. And then now we reintroduce arc 2, 4 into the network. It had a residual capacity 0, but we're increasing it to 1 because we walked along its backwards equivalent. So, or we walked along the forward arc 4, 2, so its backwards equivalent is 4, 2. Arc 2, 5 had residual capacity 1. Its residual capacity drops to 0. So now I have a backwards arc from 5 to 2 with the residual capacity of 1. And then arc 5, 6 had residual capacity 3. Its residual capacity drops to 2. And then we increase the residual capacity of the backwards arc by 1, 3. And now what we can do in this network is see if we have a path from 1 to 6. So if I start at node 1, only way out of node 1 is to go towards node 1 to node 3. Once I get to node 3, I can't leave node 3. There's no way out unless I go back to 1. That doesn't really help me get towards node 6. So we can stop. There is no path from 1 to 6. So that means we're done with our augmenting path algorithm. We found the max flow. In order to get the flow levels of the arcs, what we can look at is we can look at the residual capacities of their backwards arcs. So what we know currently is that I have a residual capacity of 2, 1, which implies that I have 3 units of flow on arc 1, 2. So x12 is equal to 3. x13 is equal to 3. And then looking at x24, its backwards arc 4, 2 has a residual capacity of 2, so x24 is 2. And let's look at x35. It has a residual capacity of 2. x25 has a residual capacity, or not, x25 has a flow of 1 because the backwards arc 5, 2 has a residual capacity of 1. And then what arcs are we missing here? x34 has a flow of 1 because arc 4.3 has a residual capacity of 1. And I forgot to write down the residual capacity of 6.4. So X 4.6 has a flow of 3 because X 6.4 had residual capacity. Arc 6.4 had residual capacity of 3. And then we also, last one we want to put in is X 5.6 has a flow of 3 on it because arc 6.5 had a residual capacity of 3. And we're good. We found the flow. We found the max flow. Now, one thing I wanted to kind of indicate is that let's look at how we can possibly get the min cut. Currently, right now, in my final network, I can only move from 1 to 3. The only node I can reach from node 1 is node 3. So let's look back at our network here. And actually, I mean, if you do the math, the flow balance will work out. And this ends up with a total flow equal to 6, which is the total amount of the deltas over all iterations of the augmenting path algorithm. So now what we can look at is I can move from 1, and this is the original network with the residual, or with the original capacities. 1 and 3 are the only nodes that have a path from 1 to 3 in the final residual network. And what I want to do is look at the cut that separates 1 and 3 from the rest of the network. If I look at that cut, the cut capacity is U12 plus U34 plus U35, which is equal to 3 plus 1 plus 2, which is 6. So if we want to find the min cut in the network as well, when we're done with applying the augmenting path algorithm, figure out all nodes that can be reached from our source node, in this case node 1, all nodes that have a path in the residual network. They're going to form one side of, if you look at the arcs in the min cut, those nodes that can be reached from the source node will form one side of the cut. And the reason why, one reason we know that this is the min cut, is because the cut capacity of this cut is equal to a feasible flow level that we identified with the augmenting path algorithm. So we know that the max flow in the network is 6 and the min cut in the network is 6. So that concludes this video, and I will see you around.